Okay, welcome back. Today we're going to be talking about logarithms. So this is section 10.2. Let's start talking about this here. And today is the 5th. Okay, now logarithms, sometimes people refer to them as logs. And the purpose for why they exist, the main idea, is that they are the inverse of exponential functions. Now what that means is, if I asked you 2 times x is equal to 8, you would divide to get x by itself. If I told you x plus 2 is 8, you would subtract to get x by itself. If I told you the square root of x is 3, you would square both sides to get x by itself. But with an exponential function, like if I told you 2 to the x is equal to 9, you can't add because you're not subtracting. You can't divide because you're not multiplying. What we have to do for something like this is we would take a log of both sides. And we're not quite at that level yet. We'll be learning that in a lesson that's coming up. But that's why we have to learn about logs, is to solve equations that look like this, where a variable is for the exponent. Now, in order to get started, let's just go over some basics. If I wrote an exponential equation like n is equal to b to the p power, where b is the base and p is the exponent, using logarithms, I could write that the exponent is equal to the log base b of n. So let me write down what I told you before. B represents the bases. P represents the exponents. And n is something called the argument. Okay, so what you're taking the log of is called the argument. A couple things I just want to point out here. The base can't equal 1, and we'll see this in lessons coming up, but for right now, it's just important to note that b can't equal 1. B has to be positive, and that our argument has to be greater than 0. All right, now these are all applying to this area right here. And this will be made clear coming up, but let me show you what I'm talking about. So it's important first that we start by writing things using this translation property. Okay, so the translation property, similar to what we just talked about, I'll just write it another way, says that if y is equal to, let's just say y is equal to a to the x, then using logarithms we could write the log base a of y is equal to x. It's called the translation property. One way that I think about this is you could write a to the x power and get y. So do a little crisscross like that. Something else that's going to be important is called the inverse property. Now with the inverse properties of logs, it talks about 2 different things. One thing is that if you're taking the log base a of an exponential base a, these actually cancel, and you just wind up with x. Another property looks like if you have an exponential function with a logarithmic exponent, the base of the exponent and the base of the log wind up canceling, giving you just x. So let's go over some examples so you can see how this actually takes place. First ones, the directions are going to be to translate. So let's take a look at this. We'll call these the first examples. Say if you had 2 to the third is equal to 8. I would like you to write it using logarithms. Well, using our translation property, this base is going to be the same base here. And if we're using the crisscross method, 2 to this power equals this number. 2 to the third power equals 8. That would be how you translate it. Let's try another one, and then we'll switch it up with logs. How about, let's say 5 to the negative second power is equal to 1 over 25. Well, written using logs, this would be the log base 5. Now if we have to do the crisscross, 5 to this power equals this number. So 5 to the negative second power is equal to 1 over 25. That's how you would write it. Let's do it backwards. What if I asked you to translate log base 8 of 1 is equal to 0? Well, crisscross, 8 to the 0 equals 1, and that makes sense. Anything to the 0 power is 1. One more example like this. What if I asked you to simplify log base 2 of 1 over 16 is equal to negative 4? Well, using the crisscross method, 2 to the negative 4th power is equal to 1 over 16, and that makes sense. You guys know the inverse property, negative exponent property, would be 1 over 2 to the 4th, which is 1/16. Next type of examples, I would like you to solve. So what if we had the log base 9 of x is equal to 3/2? Use the crisscross property. 9 to the 3/2 power is equal to x. And you should remember that 3/2, the property where x to the m over n power means the nth root of x to the m. So really what this is saying is the square root of 9 to the third power, which would give you 3 to the third, which is 27. Try another example. How about the log base 4 of 256 is equal to y? A lot of these problems, most of them, we use the translation property. 4 to the y power is equal to 256. And 256 is actually 4 to the 4th power. We talked about this in a previous section. If the bases are the same, the exponents are the same, y would equal 4. How about, we'll do a couple more here. How about the log base 1/3 of 27 is equal to y? Similar to the one we just did. 1/3 to the y power is equal to 27. 1/3 is really 3 to the negative 1st power. Well, this is 3 to the negative y would equal 3 to the third. So negative y equals 3. The powers are equal, so y would be negative 3. One more problem. How about the log base 5 of 5 to the third? Now there's a couple different ways we could do this. One is using the inverse property, where we just cancel these and we know that x would be 3. That's an inverse property, we just talked about that. Another way to do it is we could do the translation property. 5 to the x is equal to 5 to the third. Now either way that you do that, you see that x is equal to 3. Alright, so we have a couple more types of examples to do. Let's see, this is number 3. I'll ask you to simplify a few more. So let's simplify. 5 to the log base 5 of 25. Now, whenever you have a problem that says simplify, if you want, you could always make it equal to x. We don't know what it is. And actually, this is an inverse property. 5 base, the exponent base 5 of log base 5. These just cancel. And you just get x is equal to 25. So those are pretty easy. What about one like this? How about, let's say, these are all pretty easy. 6 to the log base 6 of 2x plus 3. Well, again, that's an inverse property. You could just cancel this and this. Base exponential, log exponential, those cancel. And we just get x is equal to 2x plus 3. That's what it's equal to. So, I mean, really, we could have put y here, right? Just don't be careful there. It's not saying that 2x plus 3 is equal to x, and then you bring it over. That's what it's actually equal to. That's what it simplifies to. 2x plus 3 would be the answer. All right, and let's finish with a little bit more tricky problems where we're going to be asked to solve. So let's solve, have 4 here. Log base 2 of 2 to the 3x plus 2 power is equal to 14. Well, log base of an exponential base, those would cancel. So 3x plus 2 is 14. You can bring the 2 on the other side, divide by 3, x would be 4. How about a problem like this, where it's log base b of 0.01 is equal to negative 2. Well, this we could rewrite as b to the negative 2 power is equal to the 0.01. And one thing that you'll recognize with logs is that logs and fractions go well together. Logs and decimals, they don't really play nicely. So let's rewrite 0.01 as a fraction. 0.01 is 1/100th. And 1/100th is 10 to the negative second. So you can see if these exponents are the same, the bases have to be the same. B would equal 10. All right, a couple more. To finish up, we're going to be talking about the property of equality. And the property of equality says that if we have a log, same base of a number, is equal to the log, same base of another number, as long as these logs are by themselves and they have the same base, they actually cancel each other out. So you could just cancel those. But it has to be one log is equal to one log of the same base. So let's do these last couple of problems. This is BC. Log base 8 of 3x minus 1 is equal to log base 8 of 2x squared. And just like we said, these logs are to the same base. So we get 3x minus 1 is equal to 2x squared. This is a polynomial. We should make it equal to 0 by bringing the 3x and the 1 over. If we factor, both of those would be negative. And if we set those factors equal to 0, we'd get that x is 1/2, and we get it that x is 1. Now you just want to double check, because remember what we said, the arguments can't be negative, right? So if we were to plug in 1, we'd get 3 minus 1, so that would work in this one, and 1 would also work here. If we were to plug in 1/2, 3 times 1/2 is 1.5, so this would work, and this would work. So you just want to double check your answers for these. Both of these would be acceptable answers. And then our last problem, log base 10 of t squared minus 6 is equal to log base 10 of t. These bases are the same, so we'd get that t squared minus 6 is equal to t. Just like before, it's a polynomial. We solve polynomials by making them equal to 0. Factor. We get that t is 3, t is negative 2. Now if we go to check our answer, if we plug in 3 works for both of these, but we can't use negative 2 because that tells us we're taking the log of a negative number, so that's extraneous. This would be our only answer. For homework, what I would like you to do is I would like you to please do practice 10-2, the evens. All right, good luck with that. Have a nice day.